For number 8B, look at page 353, and there's a blue box here that continues on to the next page that explains the steps you need. We're trying to find a confidence interval for our population mean. And for our example, that's the average size, the mean size of the rim diameter of the ceramic vessels. So we only looked at a sample of them. There was 10 sample rim diameters listed in problem 8. But we want to know for all the ceramic vessels, what is their average rim diameter? So we're trying to estimate that, find a confidence interval for that. And the problem doesn't tell us what the population standard deviation is. So we can't use the formulas from 8.1 because this is unknown. So we have to use this from 8.2 on page 353. And if you continue on to the next page, we can assume it's a normal distribution. So we're going to use our formula here where we have our sample mean, and we're going to subtract an error of estimation from it, and we're also going to add an error of estimation from it, and we're going to be confident that the population mean is in between. Here's another picture to help illustrate that. Our sample, the rim diameter of our sample is 15.8 centimeters. So we're going to figure out an error of estimation and add that to 15.8 and also subtract that to 15 from 15.8, and we'll have a smaller number all the way up to a bigger number, and we're going to be 80% confident that the real mean, that all of the clay vessels, if you look at all of them, their average rim diameter would be somewhere between that smaller and that bigger number. And to do that, we use the steps from page 354 now, where to figure out that error of estimation, we just need to know this formula. Now we already figured out the sample standard deviation. You do that in part A. N is the number of sample data that we have, which we had 10, so the square root of 10. And now we need this critical value, and we use table 4 of the appendix. And that's on page A10. It's at the very back of the book. So on page A10. How to read this table, here's your confidence level you're going for. So if you wanted 99% confident, you look at this column. 99.9% would be this column, and so on. We want 80% confidence. So 80% confidence, we look at this column. And in this column, you go down to one less than the number of samples that you had. So since we had 10 samples, that means we have 9 degrees of freedom as the technical term. This is the number we're going to use in our formula. So 80% and then down to 9 because we had 10 in our sample, and we always go to one less. So plug that into the formula for TC, and you should be able to figure out your error of estimation. And when you get those two numbers, you'll be 80% confident the real mean is in between them. And just as a side note, if you wanted to be 90% confident or 99%, you follow all those steps, you'll see that this range has to get bigger and bigger if you want to be more confident. And that should make sense. If you were trying to guess, based off this number of your sample, what's the real size, the real average for all of the pots, all the clay vessels, and you gave a range of numbers, the bigger your range, the more confident you are that you're going to be right. You can think of that like a sports game. If you're thinking how many points are the Pacers going to score tonight, and you could say I'm 80% confident the Pacers are going to score between 90 and 100 points. Well, you would be even more confident if you got a bigger range. If you say, hey, I'm even more confident they'll score in between that range. So the bigger your range gets, the more confident you are. You could be almost 99% confident, 99.9% that they'll score within this range. Get even bigger. So the bigger your range, the more confident you are. And You shrink it down to something really small, I think the Pacers are going to score between 95 and 99 points. I would be not very confident at all. That would be like a 10% confidence level. I would be very unconfident that it's going to happen in that range. So that was a little extra just to wrap your head around confidence levels and what they actually mean. But we're trying to find a range of numbers that we think the value is going to lie in between. In this case, our value is the average rim diameter of clay vessels.